Hey everybody, welcome to Chapter 3. 3.1, I'm just going to give you an introduction as to statements and logical connectives. We're going to learn about statements, quantifiers, and compound statements, and the words not, and, or, if, then, and if and only if, and how they look in symbolic. Connectives are the words such as and, or, if, then, and so you use them all the time, like I would like tomatoes and onions on my hamburger. The word or, you have to be careful, has two different meanings. It could be exclusive or it can be inclusive. Okay, so if it's exclusive, that means one or the other can happen, but they cannot both happen. So if I said I want tomato or onion on my hamburger, if they put both on there, then that would violate the exclusive or. Inclusive or means you can have one, the other, or both. So I would like tomato or onion on my hamburger. I could have just the tomato, just the onion, or both, and it would be fine. And that's the inclusive or. In this class, we're going to assume that everything is inclusive. A statement is something that can be judged either true or false. Okay, so for example, George Washington was the first president. That is a statement that can be made true or false, checking your facts. When you assign something a true or false statement, you said that you have assigned it a truth value. So be careful because not everything is a statement. So for example, if I said like strawberries are the best, that cannot be proved true or false, so that would not be a statement. You can have two different types of statements. You can have a simple statement or a compound statement. Simple statements just have one idea in mind. So for example, George Washington was the first president. That's a simple statement. That's either true or it's false. Compound statements start combining things together. So George Washington was the first president and he wore a wig. That is an example of a compound statement. One thing they'll often talk about is the negation of a statement. A negation of a statement is the opposite. Okay, so for example, if I have a statement that's always false and I negate it, then the negation would always be true. Or vice versa. If I have a statement that's always true and I negate it, then the negation would always be false. Quantifiers think about quantity. So words such as all, none, or some would be an example of a quantity. So you have to be careful because when you negate a statement that uses a quantifier, it will affect the quantity. So for example, if I said all of my students are brilliant, and I wanted to negate that, the negation would say some of my students are not. So notice, instead of all, we went to some, and instead of are, we went to are not. None of my students are happy. Some of my students are. So notice the none went to some. Now, you have to go the opposite way if you use the word some. If you use the word some, then you either have to switch to none or all. Okay, so some of my students are happy, the opposite of that would be none of my students are. Some of my students are not happy. The opposite of that would be all of my students are. So be careful when you negate a quantity. You have to change the quantity and you have to change the value of the statement. So this is just a visual of what I've just said. So instead of the word all, you would use some. Instead of the word none, you would use some, and so on. Okay, so for example, some telephones can take photographs. If I asked you to negate that, you would say no telephones can take photographs. Okay. Another example, all houses have 2 stories. The negation of that would be that some houses do not have 2 stories. So statements consisting of 2 or more simple statements are called a compound statement. Compound statements are going to have connective words between them. Connective words are and, or, if then goes together, and if and only if goes together. The symbol used in logic to show the negation is the tilde, and that is read as not. So, for example, the negation of P would be read not P. If you're going to use the word and for a conjunction, then you're going to use the caret, so it looks like an upside down V. The way you would read that is P and Q. The word and can also be said as but, however, and nevertheless. So for example, Green Day is not on tour, but Green Day is recording a new CD. So what you would come up with is you would come up with a letter to represent Green Day being on tour. So let's say the fact that they're on tour is letter T. And we want the fact that Green Day is not on tour. So you would use the not symbol and then the letter T. But is another way of saying and, so you would use the upside down V. Green Day is recording a new CD. So maybe recording is the letter R. So not T and R. Disjunction is the word or, and that looks like a regular V. And in this book, or is always going to be inclusive unless they say otherwise. So when you read a disjunction, you would just read it as P or Q. Okay, so for example, P represents Maria goes to the circus, Q represents Maria goes to the zoo. Write a statement in symbolic form. Maria will go to the circus or Maria will go to the zoo. Well, Maria goes to the circus is P, or is the V, and Maria will go to the zoo is Q. So it'd just be P or Q. Same symbols. P, she goes to the circus. Q, she goes to the zoo. Maria will go to the zoo, so that's Q. Or Maria will not go to the circus. So since it's not, you need your tilde, and then the circus is P. So Maria will go to the circus or not, or go to the zoo or not go to the circus. When a compound statement contains more than one connective, often they're going to use a comma. Okay, and this comma is going to help indicate the groups. When we write the compound statement, the simple statements on the same side of the comma are to be grouped with parentheses. Okay, so example. P represents dinner includes soup. Q, dinner includes salad. R, dinner includes the vegetable of the day. Okay, so dinner includes soup, comma. So that would be the soup, which is the P, comma, and, so your and symbol is your upside down V, salad or vegetable. So those, since they're on the same side of the comma, are going to go in parentheses, salad or vegetable, like that. Dinner includes soup and salad, comma. So soup and salad are going to be on the same side. Soup is P and salad is Q and is the upside down V. Or, so that would be the regular V, vegetable of the day. And vegetable of the day would be R. This time we're going backwards. So they've given us the symbols and they want us to figure out the statement. So P represents the house is for sale and Q represents we can afford to buy the house. So they want you to decode this. So P, the house is for sale. This symbol means and. This symbol means not. And the house is for sale and we cannot afford to buy it. Okay, so the house is for sale and we cannot afford it. Okay, let's try this symbol. Not P, so the house is not for sale. Or not Q, we cannot afford it. Either way, you're not getting the house. Let's look at one more. Not, and then you have the quantity P and Q. Okay, so it is not true that the house is for sale and we can afford it. And you probably want to throw a comma in there. Okay, so be careful because sometimes you'll have what's called a conditional statement. A conditional statement is an if-then statement, and it is symbolized by an arrow that points to the right. So an example would be, if Susie goes to the movie, then I'll go. An antecedent is the first part of the statement, so that's if Susie goes to the movie. The consequent is the second part, then I'll go. Okay, so it is read, if P, then Q is how you would say that. Okay, so for example, P is the portrait is a pastel, Q is the portrait is by Beth Anderson. They want you to write, if the portrait is a pastel, so that would be if P, then the portrait is by Beth Anderson. If P, then Q. If the portrait is by Beth Anderson, if Q, then the portrait is not a pastel, not P. If Q, then not P. It is false that, so not, and then probably a set of parentheses. It is false that if the portrait is by Beth Anderson, then the portrait is a pastel. So notice it is false that included the whole statement. Okay, you have another type of statement called a biconditional statement. A biconditional statement is read if and only if, and typically the arrow points in both directions in a biconditional statement. And it is read P if and only if Q. Okay, so for example, Alex plays goalie on the lacrosse team, and the Titans win the championship cup. And you have P if and only if Q. So Alex plays goalie if and only if the Titans win. I wish that was the case if you're a goalie, but not always. Next, Q if and only if, not P. Okay, so the Titans win if and only if, and some people will shorten that IFF, the Titans win if and only if Alex is not the goalie. It's kind of a bummer for him. Okay. Another statement. It is not true that Alex plays goalie if and only if the Titans do not win. So that is not true. Okay, this slide just gives you a summary of what all the symbols look like. So again, your negation looks like a tilde, and that's read not. Your conjunction looks like an upside down V, and that is read and. I kind of think it looks like an N, and I think N and. That's the way I go with it. Disjunction looks like like a regular V, and that's read or. The arrow that points to the right is read if then, and the arrow that points both directions is read if and only if.